sum of the squares of the predicted scores is 100. So which one of these would be the predicted scores?
SSE.
No, that's the errors.
Oh,
These aren't
here,
the
just
predicted
this
scores.
one.
So this would be the 100.
Yeah.
And what then is the sum of the squares errors is 200, right? So what they want to do is to find r squared. So remember, this equation takes the form 1 equals r squared plus SSE over SSY. So how do you proceed? So first, what is 100 plus 200? Bingo. Now let's divide both sides by 300. And do we get a 1? Then what is r squared? R squared is 1/3. All agree that r squared is 1/3. 100 over 300, 1/3. R squared is 1/3. And then, what, okay, now they write that as R2, but that just means they don't know how to make a superscript. Okay, so that's done. Now, let's go to number 9. Number 9. A sample of X and Y scores is taken. So the one that we just did was number 5A. So this one is number 5A. Okay? Now I'm going to erase it, and I'm going to do number 9. Number 9, a sample of x, y, and taking. SSY prime is 300. Where do I write the 300? Roughly there. SSE is 500. And n equals 50. So find SSY. Take your time on that one.
800.
Well done. 800. SSY is 800. All in favor?
But Rob says SSY, so they gave you SSY.
They gave you SSI prime.
Read carefully. Focus. Open eyes. It gave you, careful, it makes a difference. Unless you had a bad printer. Okay? Now they want to find the standard error of the estimate. And the standard error of the estimate is defined as the squares of y minus y prime squared over n minus 2 square root. Now, which one of these numbers are we going to use to find the standard error of the estimate? Does this look a lot like that? Does this look a lot like that? Is this known to be a certain number?
Yes.
So we're going to use it, right? So this is equal to square root of 500 over 48. Which comes out to be
3.22749.
3.22. Okay, good. Now, I'm not going to say anything about C, just somebody tell me the answer. What's the answer to C?
So it's 3/5, right?
That's right, 3/8. How do you get 3/8? Well, the formula that you're going to need for part C is that 1 equals r squared plus SSE over SSY And the formula that you have is 800 equals 300 plus 500. So this is simply going to become that divide everything by 800. And 1 is equal to 3/8 plus 5/8. So this is clearly r squared, 3/8. Okay, now we've established that the standard error of the estimate is equal to the square root of the sum of x of y of y minus y prime squared over n minus 2. Standard error of the estimate. Now, the standard error of anything, the t-value for anything is equal to the statistic value minus a hypothesis value over the standard error of the statistic. So this is a general formula for t-values. This is a general formula for t-values. The statistic minus the hypothesis over the standard value of the statistic gives you the t-value. This is a generic formula for t-values. Now, if we are looking at the slope of a regression line, and in our data it does have a certain slope. Slope equals b, right? Now, if we want to put that back into population, we can only assume that in the population there's no correlation, which means that the regression line is flat, agreed? It has no slope. So our hypothesis is 0. So hypothesis slope b So we want to find the standard error of the slope. So the standard error of the slope because from one sample you're only going to get one slope. But if you take a large number of samples, you're going to get a large number of slopes, agreed? And that's going to be a normal distribution, and it's going to have some standard error. So if you made a distribution of all of the slopes of all of the samples, then what would the standard error be? Well, the standard error of the slope is known to be the standard error of the estimate divided by the square root of SSX, where SSX is equal to the sum of x minus the mean of x quantity squared. Now, this is not proved, and I doubt very much if it's going to be proved at this level of the course, at a course of this level, but it's simply given to us, and it happens to be given to us on page I believe 481. Uh, 480. 480, okay? So now in the problem that you did on the whiteboards, before you can find a t-value for your slope, you have to find the standard error to put in the denominator. What you need to do to know whether your slope is significant, this is your statistic. This is the b that you found. What was it that you found? What?
1.13.
Yeah.
1.13. And the hypothesis value was 0. You assume it's flat. So now you can find a t-value for it, and as soon as you find a t-value, you can tell if it's significant. using the t-table, but you have to find the standard error of the statistic, and the standard error of the slope is equal to the standard error of the estimate over SSX. And the standard error of the estimate is the sum of the residuals over the n-2 quantity square rooted. Now, this is going to require you to put one more column in your tables. Did they get erased?
No, they're just in the back.
That one looks erased.
Yeah, I erased mine.
Well, you need one more column. So what is the y prime column? What was the equation for y prime? Y equals 1.13 capital X. And what was the y-intercept? 7.8. So now what you have to do is take another column. For every x, you have to generate
It was 3.12.
3.12. Now what you have to do is for every x, you have to generate its y prime, which is its point on the regression line. What's the matching y prime for every x? Once you have the matching y primes, you can generate S error of the estimate. Once you have the error of the estimate, you can generate the error of the slope. Once you have the error of the slope, you can get the t-value. Once you have the t-value, you can go to the table and find if it's significant. Then you're going to have to figure out what to do with the 10 minutes that's left in your life after you do all of those steps. So that's what's required to finish B. Yes, ma'am?
The standard error of the statistic is the standard error of the slope.
No. The standard error of the statistic is the standard error of the scatter of the points about the regression line.
Then how does finding the standard error of the slope help us with the t-value?
Because you're looking for the significance of the slope. Before you can find the significance of the slope, you need to find its t-value and use the significance table. Agreed? Okay, you can't find a significant level without a t-value, true? And this is the formula for the t-value. The formula for the t-value involves, in the denominator, the standard error of that item that you're looking for. In this case, you're looking for the slope. I think I'm going to make a decision. I'm going to delete the topic of the standard error of the slope from our material to cover. We've got enough to cover without it, and it's going to involve a large amount of extra time to do it, and it doesn't move us that far along to know it. So I'm going to reduce that. I'm going to take out that part of 5B. We're just going to do the first part of 5B. And we're not going to mess with the standard error of the slope, because it is going to involve another hour or two of its own, and we don't get that much additional out of it. And I think there's one other question that involves the standard error of the slope, perhaps. So if there is, we're going to take that out as well. No, I don't see any others. So that's what I'll do. I'm just going to delete that particular topic. The standard error of the slope. It's very meaningful to know that this is the general formula for any t-value. It's nice to know that, but we don't need to test on it. Okay? So I'm just going to bring ourselves to a conclusion for the material that we're presenting tonight.
So for any other problem, we just do the other t-value test.
Yes, the other t-value test is included. The t-value for relationship is well included. The t-value for relationship, for correlation is r, and actually it's over this, which is the square root of 1 minus r squared over n minus 2. So it's r minus 0. So you see that what is here, by the position of its location, is the standard error of the correlation. So you see, because it's in the denominator, and this is the statistic, this is a hypothesized value of it, rho equals 0 in the population. So what is in the denominator is the standard error of the correlation.
Oh, that's why they're slow. Oh, okay.
Okay, so we brought out some good stuff there, but we're right on the edge of the stuff that you would get into in Statistics 201, the next course that you would take, if you did take a next course. We would continue on with this kind of stuff. But for right now, we're going to stop right there. So what I need to do is ask you if there are any lingering questions or points to bring up. Okay. Then I need to remind you that you need to do the homework, and then when we meet on Thursday, we will continue to go over the homework, put the stuff on the whiteboards, and then we're going to test on all of this, and predictably we'll be out of time, so we're all going to meet on Friday and have talks. But now what we're going to have to do are two things. One, we're going to have to clear this room, because there's a Japanese class coming in. So we will transfer to the room next door, 204, because Sean is going to give us his talk. So let's take 6 minutes to transfer, and we'll reconvene there at 7:10. Can you take Sean's talk?